Many of you on a previous video asked me to go deeper into side projects and weekend projects, and so here we are. I'm going to take you from start to finish and share all of the source code for my Track AI Racer. And this is a small web game I built where you can join and race around the track, hitting all of the checkpoints, and then I trained 10 AI agents to do the same thing, to both learn about how AI agents are built and trained, what their limitations are, and how reinforcement learning actually works, especially in real time. My best lap around the track was about 5 seconds 90, 5 seconds 91 with just 10 laps of practice, which is probably not enough to challenge Max Verstappen, though at the moment McLaren seem to have that clearly covered. But I'd like to see how long it takes my agents to catch up, and honestly it's kind of addictive watching them improve bit by bit over time. And I'll cover a little bit of theory and what I've learned along the way so that you can actually take this project and run with it if you want to. If you enjoy the video, then don't forget to like and subscribe, and let's dive in. To kick off our project, we needed a couple of things. First is a clear goal, and I think a lot of side projects would be a lot more successful if they have a clear set of things that they need to achieve. And it also means that we don't give up halfway because of the scope spiraling out of control, and also a finish point, because unless we want to turn our project into a product, we need to take what we've learned and then move on, because at the end of the day, it's about the experience, and that's what we're really after. We're not after days of refactoring and troubleshooting some random UI elements. So our project goals are: build a simple racing game, build an agent that can connect to the racing game and learn to race, and then build a UI that allows us to view and track the agent's progress. So with that and the constraints that it's a weekend project, so we have one day, which is probably the Saturday, to research and build, and half a day on Sunday to review. And the inspiration for this project actually comes from the YouTube channel AI Warehouse. I love their videos and wanted to see if I could achieve some kind of similar results, but this combined with my clear goals gives me a nice starting point for our project to kick off. So let's quickly run through how the Track AI game works on the back end, and feel free to skip ahead if you're not that bothered about how the actual game runs, but if you're interested then we'll just run through it very quickly. So obviously we're just importing the things we need, like the socket IO and Express and things like this, and then here we're creating a new game state, and we only really have one game state and one map, so there's only like one singular track or session. And that's one of the constraints of building projects like this, is it's not really scalable. It's only designed for this one use case. But yeah, we create our new map, and then we've got a bunch of constants. So these are just our car physics, so they're constant across all of the cars. And then we've got a bunch of endpoints. So you can see that these just return specific templates, and then some of them do lookups, for example, in the database, and then return some different data as well. And most of the front end is built by Claude. So I did quite a lot of the back end, and then Claude also helped me resolve some issues, do some troubleshooting and things like that, especially with the game loop and handling some of the socket connections. But most of the back end is built by me, and pretty much all of the front end is built by Claude, and a lot of the back end troubleshooting was supported by Claude as well. So that kind of gives you an idea of my workflow. I do like to write code myself, otherwise I don't really learn anything. But you can see there are a bunch of back end endpoints, and then we get onto the sockets, which is probably the most important part of the application. So we've got user connections, we can handle disconnects, and we can spawn cars when somebody connects, and this creates like the initial state. So you can see that they've got like a username, an ID. This is the starting point on the track, which we'll see in a second. So you start at the start line, for example, and other things that I had to put in are like the lap start time is set to null, so it doesn't actually start your lap time until you put some kind of key input. So resetting, if you sit there for a little bit, it doesn't tick up on time, if that makes sense. And then we've got things like scoreboard entries, game states, the current checkpoint. So the checkpoint changes, so you need to hit them in order. You need to hit checkpoint 1, 2, and 3, and this is really important. So before I'd implemented a way of figuring out what the next checkpoint is, the agents had no idea which checkpoint to go for, and I thought that, yeah, they'll probably work it out eventually that they need to hit checkpoint 1, checkpoint 2, checkpoint 3, but then if I ever changed it, all of the training that we'd done would be completely useless. So what I did is added the ability for agents to understand where they are in relation to the current checkpoints, and then obviously they're going to learn that they always want to be going for the next active checkpoint, if that makes sense. And then we've got reset car, and we've got handling car inputs, so we can broadcast our states and broadcast our updates. And then we're also handling disconnects, and we can request cars as well, so we can see what's happening on the track with the other cars, which we'll see when we see the agents running. And we've got the update physics, so this is basically just handling the inputs, doing some basic maths, and then giving an output so the cars can figure out what's actually happened, what's the results of their input. So that is, I don't know, 20 lines of advanced physics of how complicated my track racing game is. Obviously it's very simple, but that's it. And then check lap progress, and not too much else that we need to worry about. And then some standard node stuff just to handle the server as well towards the end. So that kind of gives you like 386 lines of code. Obviously there's quite a bit of front-end code as well, and styling and templates and JavaScript. But for the back end, it's pretty lightweight. And I think when you're doing a weekend project, keeping things simple, and I did things like you can't create multiple sessions, you can't create multiple tracks. All of that would be nice, but all of that is also kind of a waste of time. Like I could do that, but it doesn't really, I'm not learning anything new when I do that. This is all about getting the agents up and running and connecting and seeing how they react when we add some reinforcement learning to them. So with that, let's take a look at how the agents are set up.
Gain a competitive edge with industry-recognized TCM security certifications. Our certifications are acknowledged by leading cyber professionals and organizations worldwide. Equip yourself with credentials that speak volumes in the cybersecurity community. Elevate your professional standing at certifications.tcm-sec.com. Be recognized and be respected.
So now with the game code kind of out of the way, let's take a look at how the agent is set up. And I'll see if I can struggle through this because, as you know, I'm by no means an expert in this area, but I will just explain to you the things that I found and implemented based on, the day of research that I did. Essentially, overall, what this does is each agent connects to the game using WebSockets, and we saw the WebSockets in the game code. It receives a current car state, so this is just position, angle, and speed, and then it picks one of the few simple actions. And this is the first thing here. We have a limited set of actions it can choose from. And then based on that, it will receive a reward. And then over time, it updates the queue table to learn about what to do in each situation so that it can complete laps faster. So this is reinforcement learning using queue tables in a nutshell. So here we have the turn right and turn left both equal to false. So this is just going straight forward. We can then turn left, we can also turn right, and we can also brake. And note that the accelerate for the agents is always on. So they're always accelerating, always going forward, but then they have these other 4 actions, which is basically don't do anything, turn left, turn right, or brake. So the first big thing I suppose that we need to look at is the alpha, gamma, and epsilon values. And these are important for the queue learning. So alpha basically means the learning rate. So how much to trust new experiences. And the higher the value, this means the agent might adapt quickly, but it might forget old actions that were good. Gamma is the discount factor. So how much to value future rewards. So if we put it at 1, for example, it's going to be more like long-term planning, and if it's 0 or 0.1, it's going to be more greedy and try and go for immediate rewards, for example. And then we have epsilon, which controls like the exploration rate. So here we've got 0.1, which is 10% of the time just take a random action, do something completely nuts and see how it goes. And this is so that it doesn't just keep doing the same thing over and over again. And I think based on these values, obviously your agents are going to train much faster and much more effectively or less effectively. And kind of one of the next steps that I want to take is looking at adapting the values over time based on where they are in their learning journey or based on how we see that they're doing. And then we might increase the exploration at the start and then decrease it over time, for example, to kind of like tighten things up, or maybe the other way around, so that might give different results. The next big thing that we need to look at, because a lot of this is just connecting to the game and like logging here, so I'm logging to CSV files, is the update queue table. So this here is kind of like the most important part of the whole project. And this is classic Q learning, or at least that's what the research that I did told me. So just a heads up, I used a website called fast.ai to learn some concepts, and I also did quite a bit of Googling and reading blog posts and things like this. And the maths behind this, I don't really fully understand, but I read enough blog posts and saw enough code to basically be able to take it and implement it into my scripts, which is what I wanted. You know, that's the whole point of being an engineer, is being able to research stuff and get it to work in a certain situation or environment. I'm not necessarily a researcher. I'm not an expert in AI, so like there's a lot of deep understanding that, you know, is just not available to me and probably isn't a good use of my time to learn. But here, what we're doing is we're updating the value based on the last action and how good it turned out to be. So yeah, so basically it increases the values of actions that led to good things and then reduces the value of the actions that didn't. And the key kind of like line is this, which my face is kind of in the way. But if you want to see the maths, you can Google Q learning and really get a breakdown on what's happening and how it all works. But this is like the key to our reinforcement learning. How does it decide what's good and bad? This is something that's really, really important as well, an important part of the script, and something that if you take this, you can play with it. Somewhere down here we have the rewards. So for example, this is the base time penalty. So every tick we're getting minus 0.5. So the longer it takes, the worse the overall outcome is going to be. This is checking out of bounds. So if X is less than 10 or greater than the track width, we know that the car is basically hitting the wall. We want to keep the car within bounds. So we penalize it every time it's out of bounds, either X or Y. And then for the checkpoint here, this is basically saying if a car moved closer to a checkpoint, then give it a reward of +1. Otherwise, give it a reward of -2. So it gets penalized for moving away from the checkpoint, and it gets rewarded for moving towards a checkpoint. And I think somewhere I implemented a lap completion reward as well. So it'd get a bonus for actually completing the lap. And part of the script is it will run for 30 seconds. And then if it doesn't complete the lap in 30 seconds, it'll just reset. And it'll just take the final value and be like, okay, that was the run. Otherwise, I think when I first started testing with it, some of them would just be stuck in the corner for like an hour and then nothing happened. So implementing resets, I think, really, really helps. And then rewarding completed laps. Once they started completing laps, it kind of like slowly cottoned on, and then more laps were completed, became more consistent over time. And I think that's everything. Otherwise, the rest of it is logging, handling the connections, and things like that. And then I've got some threading as well so that I can run 10 agents at once. I was initially quite optimistic. I threw 100 connections in. The WebSockets didn't like that. A lot of things were disconnecting. It was finding it hard to maintain 100 solid WebSockets all at once. This is probably an interesting case study for training in real time and some of the real world limitations to training, in that you're going to be limited by lots of different things. So that was kind of interesting to learn as well. So that's the script. It'll be on my GitHub if you want to take it and give it a try. I'm probably going to upload it sometime next week, hopefully before the video goes live. Otherwise, harass me in the comments below and I will get it up there eventually. I'm good at saying these things on live stream, like I'm going to put it on GitHub and then forgetting. All right, so what we're going to do next is we're going to get this up and running. I have run it for a couple of hours before already, just to make sure that it actually works and the agents are connecting and learning and improving. But I'm going to run it for 24 hours and see whether after 24 hours, the agents can get anywhere near the time that we set. So I'm just going to go in, set a quick time. I won't do more than 10 laps. And then we'll set the agent off and we'll check in every 3 to 6 hours or so to see how it's going. So we've got all of the dependencies. We can start that. And then we can come into here. We've got our aiqlearn.py, and let's just Python 3 aiqlearn.py, and we're going to do agents 10. So actually, before we do this though, let's quickly set a lap. And something to note is that I did try putting in like 100 agents, but unfortunately with the WebSockets, they kept disconnecting, and there were some issues and things like that. So let's see whether we can get a sub 7 lap. No, missed. I won't do more than 10 laps if I can get. I missed again. I'm not learning very well. Oh, this is the one. This is the one. Yes. Okay, so 688. So that'll do for our lap time. Let's see whether AI can beat this. So we come back to here. We'll do 10 agents, and then I think we can switch to track view. And as you can see straight away, they love to go for the wall. So what I'm going to do is I'm going to set this back up, and then we'll leave this running, and we'll see what happens in 3 hours or so. I'm actually just going to quickly make sure that they do reset before. Yeah, there we go. Okay, so every 30 seconds they reset, they try again, and fingers crossed they slowly improve. So catch you back here in a few hours. All right, I totally missed the 3 hour mark, and I'm checking in like 5 or 6 hours later because I've been in meetings, I've had other work to do, and it looks like every bot has managed to actually clock a lap, which is quite cool. An AI bot 1 has done 8 laps, but still only 8 seconds. So this is pretty good progress, I think. I'm optimistic for like the 12-hour mark to see how that does. But yeah, I'm glad that all of the bots have actually managed to clock a lap, and all like a reasonable lap, and not just like, 25 seconds, 28 seconds. They're actually like 8 seconds, or is like, hitting every checkpoint without, doing 2 full laps of the circuit and then coming back. So yeah, not bad so far. I'll see you back here in, I don't know, a few hours before I go to bed probably. And then I'm going to check back in again in the morning. So yeah, good luck. Little AI agents, although look, they're all stuck in the corner right now, which is not ideal, but I'm still optimistic. All right, so it's a little bit later now. Not sure if you can tell from the lighting, but it's like 7 p.m. here. And let's see how they're doing. So AI bot 7 doing well. Like, so 7 seconds 21. So this is like 7.21 seconds. I think maybe I didn't explain before that the colon is not like minutes to seconds, it's like milliseconds. So it's like seconds to milliseconds. So it should actually be just a dot. But every single bot has managed to clock a lap. Looks like AI bot 3 is disconnected for some reason. I might have to investigate what's happening there, but that's okay. Losing one agent is not a big deal. But 7 seconds. Okay, this is good. And actually a lot of them, so 7 has done 19 laps, 9 has done 17 laps, and they're doing pretty well. I think what I'm hoping to see is that at least one bot in the morning, so I'm probably not going to check again until tomorrow morning, at least one bot manages to make it into the 6 second mark, and maybe all of them may manage to make it to 7 seconds. Let's see. But they are getting more consistent, and to be fair, when we see like 10 laps, I suppose that's not that many. Like, this is complete laps over the 6-7 hours that it's been running. Yeah, it's been about 7 hours now. So It's not a ton, so I'm hoping to see some more consistency, but we'll see. And I will check back in maybe 10 hours time. Let's see how it goes. All right, and it's 24 hours later now, so let's see how they're getting on. I've just managed to, it's Saturday now, so sleep in a little bit, had my coffee. How are they doing? They've done a lot of laps, which is unsurprising because obviously it's been running for 24 hours, more than 24 hours. Didn't quite manage to break into the 6 seconds mark, but almost all of them. So it looks like bot 3 had some issue, has disconnected, hasn't reconnected. That's fine. But all of the others actually have managed to hit the 7 seconds mark, which is pretty nice. And I think 300 laps, that's reasonably consistent. So I'm kind of happy that they're actually managing to get a decent amount in. And it's nice to see them visually, apart from this guy here, not just hug the wall the whole time. So they're actually, yeah, it's like skirting away, coming towards the checkpoints and kind of doing stuff. And I think from here, my prediction is that progress would get slower and slower, so they'd make small improvements over time. And maybe after about a week, then maybe they're actually going to hit like a consistent lap every single time, or when it misses, they'll be able to loop back round, tag the checkpoint, and then continue. So this is my prediction. I might move this over to one of my boxes on Proxmox and then leave it running while I'm at DEF CON next week and see what a week of training does. Obviously, the limitation here, once again, is that it's all real-time learning. So, we could up the tick rate of this game to 10,000 and then just train stuff very, very quickly. But where's the fun in that when you just get results instantly? I might do that in a couple of weeks once I'm back, just to see, what the limitations of reinforcement learning using Q tables would be versus the like a neural network, for example. So I'm going to try some different approaches. I might tighten up the game a little bit, maybe change it. We'll see. If the bots get a lot better, then I will probably implement different tracks. And so each train them and then have random tracks, and we'll see. That, or adding in collisions so they're actually racing. That could be fun as well. But yeah, I'm pretty happy with the progress that they've made. It's clear that they have made good progress, which is, I think, the whole point, right? And I think we've learned a little bit about some of the limitations of real-time reinforcement learning, how long it's going to take. Obviously, this is a very simple scenario, more complex than noughts and crosses, but way less complex than a real-world driving situation or a more complex 3D game, for example, that has a lot more variables. But, still a good starting point. And proud of my little agents, apart from Agent 3 that just died somehow. Yeah, nice. So overall, I'm pretty happy with the results of my weekend project. However, there are a lot of things that I'd like to experiment with or improve on. And honestly, with a project like this, you could easily sink weeks or months into making improvements or just adjustments. But for me, if I'm going to continue working on it, it's because I want to learn new things. So with that being said, the things that we could explore from here are different approaches to reinforcement learning. So for example, we could look at deep queue networks. So currently we're using a tabular queue learning where each discrete state maps to a table of values, but in the real world, states are often too large or continuous for a table, so we can replace our pickle queue table with a small neural network, and this might improve our agent and lead us into new areas or results. We could also look at policy changes over time, or maybe introduce some kind of curriculum learning so that instead of just one reward set, we actually change the rewards as the agent progresses. and we can maybe train the model on a human lap and then use that as a baseline and let it copy our behavior and then make improvements from there. All of these things are going to deepen our understanding and keeps us away from just making the leaderboard look better or spending a couple of hours adding animation tweening to make it run smoother, fancy graphics and checkpoints, things that are fun to build and satisfying to see, but ultimately a waste of time because once again, weekend projects are all about the learning experience, not necessarily about creating a good looking product. I hope this video gave you some insight into how I approach learning new things, and if you want to see more videos like this, be it weekend projects or more on my foray into the world of AI, then let me know down in the comments below and I will catch you next time.